Welcome to Module 2, Lesson 2, Scientific Notation with Positive Powers of 10. Today we're going to talk about using numbers expressed in the form of single digit times a whole number power of 10 to estimate very large numbers. Alright, so scientific notation is a method of expressing very large and very small numbers as a product of a number greater than or equal to 1 and less than 10. And a power of 10. All right, so in scientific notation, what you should notice is that your number, the first number that you have, is greater than or equal to 1 and less than or equal to 10. So that number has to be bigger than or equal to 1, but less than or equal to 10. All right. So let's take a look at this. So we have the weights of these various creatures and all our whales, it looks like, and we are going to move the decimal point in the blue whale's weight, so in the 250,000 to the left as many places as necessary to get that number that fits in here. So we need a number that'll fit between 1 and 10. So if I have that 250,000 and I move it 1, 2, 3, 4, 5 places. So if I move that decimal and put it between the 2 and the 5, it gives me 2 and 5/10 because I can take all these zeros off. This number fits the criteria. So 2 and 5/10 does fall between 1 and 10. So when I did that, I got 2 and 5/10. Okay, so then now I'm going to take 250,000 and I'm going to divide it by my answer to A. So I'm actually going to pull a calculator out here to show you what we're doing. There we go. So 250,000 divided by 2.5. You'll notice that I got 100,000. Okay, so I got 100,000. So 100,000, and I'm going to write that as a power of 10. So to do that as a power of 10, remember the number of zeros tells me the power of 10. So in this case, this is 1, 2, 3, 4, 5 zeros. So this is equal to 10 to the 5th power. So then now I would use that to represent my answer in scientific notation. So instead of the 250,000, it would now be 2 and 5/10 times 10 to the 5th power. So now we can do the same thing to find the rest of the sharks. At first we did the the rest of the whales. At first we did the blue whale, now we're going to do the gray whale and the whale shark. Right? So with 41,200, moved it until I got between the 4 and the 1. So this would be 4 and 12 hundredths. So if I take 41,200 and divide it by 4 and 12 hundredths, I get 10,000. So if I take this and divide it by this, I get 10,000, which is 10 to the 4th power. So that tells me that it'd be 4 and 12 hundredths times 10 to the 4th power. All right, so here we're more so taking a look at how it works and what's happening. Yes, there is a little shortcut, which we'll talk about. But again, if you take your original number and divide it by that number between 1 and 10 that you get, it'll help you determine if you got the correct power of 10. So how many places to the left do we move the decimal point to write 41,200 in scientific notation? So if you take a look at what we did, I'm actually going to change my pen to red. The decimal point always starts at the end, and I moved it 1, 2, 3. Don't double count the comma. I moved it 4 places. Okay, and then the exponent 1, 2, 3, 4. Did I do that incorrectly on this one? No, I didn't. Okay. So the exponent then, when I look back, my exponent, so what is the exponent? The exponent was 4. Do you think there might be a connection between how far we move our decimal and the exponent? Just a thought. All right, so we're going to try using this method again with the division. Like I said, we'll talk again about how to do it differently later. So we have the distance from Earth to the Sun at about 93 million miles, and we're going to write this distance in scientific notation. So first, we have to move the decimal point in 93 million to the left until we have a number between 1 and 10. Okay, so again, I'm going to do this in red, so that way we can see it. So we have it 1, 2, 3, 4, 5, 6. Okay, so now we've moved it, and we got 9 3/10. So now we're going to divide the original number, 93 million, by 9 3/10. Okay, and when I do that, pull this into view for you, 93, 1, 2, 3, 4, 5, 6, divided by 9 3/10. I get 1, 2, 3, 4, 5, 6, 7, so I get 10 million. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, comma, 1, 2, 3, comma. This written as an exponent would be 10 to the 7th power. So then I know that I take my 9 3/10 and I multiply it by my 10 to the 7th power, and that gives me my answer in scientific notation. Sorry, there's not supposed to be a period there. There we go. All right. So here we go. Let's go ahead and go to the next page. So you're going to write each example in scientific notation. Again, what I would like you to do for this one is I would like you to use the method that we're using where you're doing the division. Okay, so I gave you some space to show your work. Please show your work for each of these problems, and when you come back, you can check your answer. All right, so for the first one, you should have gotten 6 4/10 times 10 to the 3rd power. And how that ended up working was you ended up with 6,400 divided by 6 4/10 gave you 1,000. On the next one, you would have had, so we have 570 billion, and we'd have to divide that by 5 7/10. And when we do that, we would get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 3, 1, 2, 3, 1, 2, 3. Whew, we would get 100 billion. So that would give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So that means that this would be 5 7/10 times 10 to the 11th power. And in this case, you have, let me get another color, 9 4 6. Make sure I'm writing all my numbers down correctly. 9,461,000,000,000, and you would have divided that by 9 461,000,000. And when you did that, you would have gotten 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1 trillion. And here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. So that tells you you would have had 9 461,000 times 10 to the 12th power kilometers. All right, so with all the times that we've done this, you've probably noticed that the number of times that you moved your decimal to get your number between 1 and 10, it very closely mirrors something else in the problem. So we're going to take a look at that for example too. So we looked at how it works, now we're going to look at using it in a more simplified manner. So for step 1, right, so for step 1, we are going to use the exponent of the power of 10 to see how many places to move the decimal. So previously, we were saying, okay, well, the number of places I move the decimal turns into my exponent. Well, now we're going to go backwards and change it from scientific to standard. So here, this tells me I need to move my decimal 6 places. All right? So then what I'm going to go ahead and do, since I have to move it 6 places, I'm then going to place the decimal by taking the 3 and 5 tenths and moving that decimal 6 places to the right. Now when I move it once, I get to the end of the 3 and 5 tenths, so every time after that, I have to add zeros back on. So then in this case, my answer would have been 3 and 5 tenths times 10 to the 6th power, written in standard notation, is 3,500,000. Okay, so let's look at the vice versa here. So here, if we would have had the 3,500,000, and if we were going to go to scientific notation, we would have taken that decimal and moved once, twice, 3 times, 4, 5, 6. So we would have moved it 6 places, which means my exponent would need to be 6. And then my number would just be everything without the zeros. So it would have been 3 and 5 tenths times 10 to the 6th. All right, so let's look at the exponent in 3 and 5 tenths times 10 to the 6th. So the exponent is 6, even though there are only 5 zeros. Why does this work? Well, it works because if you take a look at how we moved it, that first move was getting around that 5. So if we look here, it was getting around this 5 right here. So the number of zeros doesn't always mean that that's the number of times it's going to move, because of the fact that you might have some other numbers within your problem. All right, so for my answer here, I can put the decimal moves 6 places because not only did it have to go past the 5 zeros, but it also had to get past the 5 to make the number be between 1 and 10. Add a little space here so you can see both of those. So again, we had to go around these zeros here. So we went around these 5 zeros. Then we also had to go one more time around that 5, and that's why it was 6. So what is the exponent on 10 when we write 5 and 3 tenths in scientific notation? Well, this decimal isn't going to move at all. And think about what we know about our powers and our laws of exponents. Since the decimal isn't moving at all, the exponent would be 0. And then remember, anything to the 0 power is equal to 1. So this would be 5 and 3 tenths times 1, which is 5 and 3 tenths. Okay, so now you're going to go backwards and you're going to move your number from scientific notation into standard form. I gave you some space to show your work. When you come back, you can check your answer. All right, so here you should have gotten all these extra zeros. So in this case, you should have gotten 7,034,000,000. And then in the next one, so this would be 2. So again, 1, 2, and then 3, 4, 5. So we have to add those zeros. So in this case, we would have gotten 2, 3, 6, and added 3 zeros, which gives us 236,000. All right, and then the mass of one roosting colony of monarch butterflies in Mexico was estimated at 5 times 10 to the 6th power grams in standard notation. Now in this case, because there's nothing after the 5, we can just add 6 zeros. Because immediately after, so here's the decimal, immediately after we have to add a 0. So in this case, the weight was 5 million grams. All right, so you have your problems here for your guided practice. Remember that you write an exponent, so everything's going to be 10, and then your caret, and then your exponent goes here. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.